Here's the heart of the swash plate assembly. It's the uniball. The uniball moves up and down, and we'll move the entire swash plate up and down. Here's our swash plate assembly. On the top, we have our rotating portion of the swash plate, and below we have our stationary portion. When I push this lever down, you get a collective input, and that's going to collectively move the pitch of the blades. It's going to level the head off, or level this out, and show you that in this position, the swash plate doesn't move very much as it rotates around. So that would maybe simulate a hover in calm air. And as the pilot wants to take off, they're going to move the collective and move the uniball up and down, the whole swash plate up and down. Now, if I rotate this, you can see that that's a cyclic input, and it tipped the swash plate. And as I move the collective up and down, you can see that it would move both pitch links up and down collectively, and the swash plate would move it kind of independently to tip the rotor disc in flight. And that's the swash plate assembly. The cyclic and collective mix into this mixing unit, and this is collective input.
Cyclic.
This moves up and down. It's moving everything equally. You can see that. And as the pilot puts in some cyclic
forward, cyclic aft, cyclic left, cyclic right, cyclic center.
It gives different inputs. Now they call this thing the broom closet, and it sits behind the pilot seats and goes up into the deck of the helicopter up on top. All right, so here we are again with the Bell 206 rotor head, just showing you what features it has. We have our pitch links with a fine thread up top and a coarse thread on the bottom. You want to make sure you get that orientation right. That may be wrong. You want to follow what's in the maintenance manual and which way those are installed. And the pitch links are attached to a small trunnion here, a little bearing. The bearing is connected to the pitch horn, and the pitch horn is going to move the blade around the feathering axis. Now, as I rotate this, what I've done is I've put the swash plate on, tipped it on as tight an angle as I could get it, and what that means is that it's a full cyclic input in one direction. And this is going to give us the most amount of deflection I can get on this rotor head assembly. What we're going to notice is as I rotate it, you're going to notice the blades are going to change their pitch as we rotate it. So I'm going to try to rotate it without tipping it. So you can see we have, this would be, if we were in forward flight, this would be like an advancing blade where it's starting to lower its angle of incidence, and the opposite side is the angle is quite steep. So here we go, this one's going to start to just increase its angle of attack as that one's decreasing. And remember, due to gyroscopic precession, the inputs come out 90 degrees later than the outputs. There we go, that's the cyclic input.